Hello Synapse community, my name is Vengatesh Parasuraman and I'm a Senior Program Manager on the Azure Synapse Analytics Team. Welcome to the Azure Synapse Security Deep Dive series. In the last video, we saw network isolation with managed VNets. In this video, I'm going to talk about inbound network security in Synapse. Before we dive into this topic, let's cover some basics. So, what are inbound connections? Any connection that is coming into the Synapse workspace to access the Synapse resources is called an inbound connection. An endpoint provides this point of incoming connection. Each Synapse workspace comes with three distinct endpoints: a dedicated SQL endpoint, a serverless SQL endpoint, and a development endpoint. Dedicated SQL endpoint provides access to the dedicated SQL databases within the Synapse workspace. Similarly, a serverless SQL endpoint provides access to the serverless SQL databases within the Synapse workspace. Both these endpoints accept connections on TCP port 1433, which is the standard port for TDS or Tabular Data Stream Protocol. You can use any SQL client tool such as SSMS or Azure Data Studio to connect to this endpoint and execute SQL queries on these databases. A development endpoint provides access to the Apache Spark pools and the Synapse pipelines within the Synapse workspace. This endpoint accepts connections on TCP port 443, which is the standard port for HTTPS traffic. You can use our Synapse.NET SDKs or any REST API client to connect to this endpoint and submit Spark jobs, create and run Synapse pipelines programmatically, and perform other management and data plane operations on your Synapse workspace programmatically. So, if you want to secure your incoming connections to your Synapse workspace, all you need to do is secure these three workspace endpoints. Let's see how we can do that. When a Synapse workspace is created, all the three workspace endpoints are public endpoints by default. What this means is, if we do an NS lookup of any of these fully qualified domain names, we get a public IP address. And as such, they can be accessed from any network on the internet, including the networks which are outside your organization. So, in order to protect your Synapse resources, every Synapse workspace comes with a default firewall which blocks all incoming traffic to the workspace public endpoints, except from the list of public IP addresses that you specify in the firewall rules. To further protect your endpoints, Synapse automatically provides basic DDoS protection, which is called the Distributed Denial of Service Attacks protection, that includes active traffic monitoring, always-on detection, and automatic attack mitigations. In addition to these protections, all inbound traffic to the workspace endpoints are encrypted in transit using the Transport Layer Security Protocol called TLS. We ensure that all network connections comply with a minimum standard of TLS 1.2. Even with all these protections, you can further secure your inbound connections by completely disabling the public network access altogether. You can do so when you are creating the Synapse workspace. When you enable Managed VNet, you will get the option to disable the public network access. You can also disable it after the workspace has been created under the networking section. But please note, this option is available only for workspaces with managed VNets. When you disable the public network access, you can ensure that all inbound traffic to the Synapse workspace goes through the private endpoints only. So, what are private endpoints? An Azure private endpoint is a virtual network interface with a private IP address that's created in the customer's own Azure virtual network inside a subnet. Each Synapse workspace should have three separate private endpoints created, one for each sub-resource. These private endpoints are powered by Azure Private Links, and the traffic stays entirely within the Microsoft backbone network and never traverses the internet. Once we create these private endpoints and do a NS lookup on any of these fully qualified domain names, now we get a private IP address. So who can access these private endpoints? They can be accessed from only within the same virtual network and from other virtual networks that are globally or regionally peered to the VNet that contains these private endpoints, and from your on-premises networks by the use of ExpressRoute or VPN gateway. What are the benefits of private endpoints? The main benefit of private endpoints is that it's no longer necessary to expose workspace endpoints to the public internet. When it comes to security, the less exposure, the better. Private endpoint is mapped to an instance of a PaaS resource instead of the entire service. In the event of a security incident within a network, only the mapped resource instance is exposed, minimizing the exposure and data leakage from other instances. Private links works across Azure Active Directory tenants and regions. So it's possible to create private endpoint connections to Synapse workspaces across tenants and regions. In this case, it goes through the private endpoint connection approval workflow. The resource owner controls which private endpoint connections are approved or denied. The resource owner is in full control of who can connect to their workspaces. Well, that wraps up our video for today. Thanks for watching, and don't forget to subscribe, like, comment and share. Again, my name is Vengatesh Parasuraman, and you can find me on LinkedIn and Twitter. Signing off now, and I'll catch you on the next one.